Good morning, Professor. I have completed the midterm assignment you have provided, and so this is the essay, and it talks about how to turn Turing machine to a multiprocessing machine, and the main idea is to have multi-tape and multi-head to perform parallel operation, and using this tuple, we can define the states, input, and the transitions. And based on that, we can achieve some part of parallelism. Even though we can achieve some part of parallelism, so it's not fully efficient, and this is a limitation. And so it can bring some speed, but it won't give much efficiency. So this is what the observation I made while doing this paper, and I have implemented that in using C#.NET. And so this is the parallel Turing machine class, which 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 has a list of heads, which means which can have uh, a number of tab, and for each tab there will be a head. So tab head. So this can have its own read write method, and it can move left, move right, based on the transition what we have provided. So this holds tape. The tape is a array of character, and that is defined while creating the PTM class, PTM object. After that, and transition. The transition is defined by state, the current state, and when we read the symbol, we have to write. We have to change the state and write the new symbols and move the direction. So this is defined in the transition um, class, and based on uh, the the configuration what we have provided here, uh, the parallel Turing machine will execute the function. And the example what I have taken is so full adder. So full adder truth table, as we know, this is the truth table. Um, so tape 1, 2, 3 mm, will have the input like this, and tape 4 and 5 will have the output. The sum will be on tape 4, and carry will be stored on tape 5. So this can be done using 3 tapes as well. Uh, but so to demonstrate the increased power, I try to check with five tapes. And so these are the transitions I have identified. And since it is a linear operation, like, so we can move from left to right. So the transitions are only to right. And initially, input tapes like uh, tape 1, tape 2, tape 3 will have the input, and and blank state will be there in tape 4 and 5. So based on calculation, it will be again filled with the output. So for this input, it has to change to the next state S1, and it has to update this value, and the the tape head should move right after this transition. So that is defined here. So all the transitions are defined here. So based on the transition and program, we are giving the tape input. Tape input is given as like this. So first tape 1, tape 2, tape 3, and these two are output tapes, tape 4 and 5. So when we execute, so we are creating a we are creating a parallel Turing machine object, and we are executing it. So when we execute, so what we need to do is we need to check the current state and against the transition, each entry in the transition, and we need to read the tape and check whether it is defined in the transition. If it is found, we need to change the state. We need to change the state and write the new output symbols what we have provided in the transition. So that way it will be updated. Right tape will also shift the head position. So it will write and shift the position based on the configuration what you have given. So based on that, it will work. So I have tested it. And for this input, for this input, after executing, so we are getting output, this output, and carries are updated appropriately here. This is carry, tape 5 is carry, tape 4 is sum. Thank you, Professor.